Welcome to this video on rigid transformations and congruence. Students use rigid transformations to generate shapes and to reason about measurements of figures. They will also learn to understand congruence of plane figures in terms of rigid transformations. Here are the essential vocabulary words that will be introduced throughout the unit. Alternate interior angles, clockwise, congruent, corresponding, counterclockwise, image, reflection, rigid transformation, rotation, sequence of transformation, translation, transformation, transversal, and vertical angles. Students will learn to describe the movement of two-dimensional shapes with precision. Here are examples of a few of the types of movements they will investigate. In each image, shape A is the original and shape B, C, and D show three different types of movement: translation, rotation, and reflection. Students will also experiment with shapes and drawings to build their intuition by cutting shapes out, tracing shapes on tracing paper to compare with other shapes, drawing shapes on grid paper, measuring lengths and angles, and folding paper. Students will investigate rigid transformations, which is the name for moves and sequence of moves that preserve length and angle measures like translations, rotations, and reflections. For example, in this image, the triangle ABC was reflected across line AC and then translated to the right and up slightly. When we construct figures using rigid transformations, we know that the measures of the images of segments and angles will be equal to the measures of the original segments and angles. Students will learn about congruent polygons. Congruent is a new term for an idea we have already been using. We say that two figures are congruent if one can be lined up exactly with the other by a sequence of rigid transformation. For example, triangle EFD is congruent to triangle ABC because they can be matched up by reflecting triangle ABC across line AC, followed by the translation shown by the arrow. Notice that all corresponding angles and side lengths are equal. How do we know that two figures are not congruent? If there is no correspondence between the figures when the parts have equal measure, that proves that the two figures are not congruent. While each of these two polygons have 6 sides and 6 vertices, and we can make a list of corresponding angles at the vertices, these figures are not considered congruent because their side lengths do not correspond. The figure on the left has side lengths 3, 2, 1, 1, 2, 1. The figure on the right has side lengths 3, 3, 1, 2, 2, 1. For the last part of the unit, students will use the congruence to investigate some interesting facts about parallel lines and about the angles in a triangle. Students will start discussing angle pairs. When two lines intersect, vertical angles are equal and adjacent angles are supplementary. That is, their measures sum to 180 degrees. For example, in this figure, angles 1 and 3 are equal. Angles 2 and 4 are equal. Angles 1 and 4 are supplementary, and angles 2 and 3 are supplementary. When two lines are cut by another, called a transversal, two pairs of alternate interior angles are created. Interior means on the inside or between the two parallel lines. For example, in this figure, angles 3 and 5 are alternate interior angles, and angles 4 and 6 are also alternate interior angles. Alternate interior angles are equal because a 180-degree rotation around the midpoint of the segment that joins their vertices takes each angle to the other. A 180-degree angle is called a straight angle because when it is made with two rays, they point in opposite directions and form a straight line. Students will experiment with angles in a triangle. They will find that the sum of the measures of the three angles in each triangle is 180 degrees, the same as a straight angle. Through experiment, they will also find if we add the three angles of a triangle physically by cutting them off and lining them up, the vertices and the sides, then the three angles form a straight angle.